In this section, we're going to be talking about balancing chemical equations. So in the last section, we talked about the different types of chemical reactions that you'll see. Now we're going to talk about making sure that both sides are basically equal to each other. Okay, so a balanced chemical equation accounts for every single atom in the reaction. And this ties into the principle of the conservation of mass. Basically, you can't create or destroy atoms. Okay, so you have to be able to account for every single atom that you find in the reactants in the products as well. So first thing you want to do in order to balance a chemical equation is identify the number of each element that's on both sides of the reaction. So this is kind of your starting place. You don't have any coefficients, which are the large numbers in front of your compound, okay? And so you just want to figure out how many atoms of each element you have on the reactant side and also on the product side. That gives you a pretty good starting place for knowing what you still need to balance. Second, I recommend that you first focus on elements that only show up in one compound on each side of the equation and balance those first. Okay, make sure that the numbers on either side of the reaction match. Okay, now I say to focus on these elements that only show up in one place on both sides of the equation because generally you can balance them and then fill in the gaps with everything else. Okay, and you'll see how that works in just a little bit. And then third, you're going to balance the remaining elements. Okay, so this is kind of a running tally of how many atoms of each element you have until you get it so that the tallies match on either side. Okay, so this one is easiest to kind of explain by going through it. Okay, so we have our reactants. Let me get a pen here. We have our reactants on the left side, and then our products on the right side here. Okay, so the first step is just to go through what we have on the reactant side and what we have on the product side and figure out how many atoms of each element we have. Okay, so here you can see there's a 2 after the sodium, so we have 2 sodiums. Right here. We don't have a number after the sulfur, which means that it's just 1. Again, don't have a number after the silver, so that is also 1. And then with the nitrate, we have 1 nitrogen and 3 oxygens. Okay? Now, if the polyatomic ion, like this nitrate right here, if it stays together on both sides of the equation, you can count it as one thing. So I could either write it out as each individual element, or I could just write I have an NO3 and I have 1 of them. Okay? And then just do the tally like that instead. It's up to you how you want to do that. Okay? Next up, okay, we look at our products. So we have 1 sodium here. We have 1 nitrogen and 3 oxygens, or if you're doing it by polyatomic ion, you have 1 of your NO3s. Okay, here we've got 2 silvers and 1 sulfur. Alright, so now with it listed out like this, especially as we have the elements in the same order on both sides of the reaction, it's pretty obvious to tell which of your compounds are not balanced or which of your elements are not balanced. Okay, so on the reactant side we have 2 sodiums. But by the time we get to the products, at the moment, 1 of them has disappeared. Okay? That's a problem. Now, in the reactants, we also have 1 silver atom, but when we get to the products, that's doubled. Okay? So we have to be able to account for those excess sodium and silver ions. Okay? So, because we need to balance our sodium, easiest way, just go ahead and start with the sodium. Put a 2 here. Okay, now we're going to cross out this, well, maybe, this 1 after the sodium, and we're going to add in a 2. Okay, because now we have our coefficient right here tells us that we have 2 of these NaNO3s. Okay, which means we have 2 sodiums. We also have 2 nitrates. Okay, so if you're counting just by polyatomic ion, you would double that there. If you're counting by each individual element, you double your nitrogens, double your oxygens. Okay, well that looks like we've gotten things all screwed up. Okay, because now we have extra nitrogens and extra oxygens, right? And still have our extra silvers, but now at least we have our sodiums balanced. Okay, well, let's go ahead and start with our silver and balance that. So we have 2 silvers on the right side and only 1 on the left. So if we put a coefficient of 2 in front of that silver containing compound, now we've doubled our silvers, so we have our first 3 elements balanced. Okay, but because that 2 applies to everything in this compound, we've also doubled the nitrogens and the oxygens, okay, which also results in doubling that polyatomic ion. And now, if you look straight across, okay, you'll see you have 2 sodium ions on both sides, 1 sulfur, 2 silvers, 2 nitrogens, and 6 oxygens. So they are completely balanced. Okay, so a note, if the coefficient, which is the number in front of the compound, is 1, you do not need to write it. You can if it makes you feel more comfortable, but it's completely unnecessary to write it. Okay, if there is nothing there, it is assumed to be 1. Okay, and this is just going through everything that we just did, looking at your initial values, and then doubling. That is in the wrong spot, so ignore that one. It's supposed to be here. Okay, and once you double those 2 compounds, then you can see how your numbers change. You cross out your initials and then do the same over here. Okay, so that is now balanced. You have 1 sodium sulfide, 2 silver nitrates, and that yields 2 sodium nitrates and 1 silver sulfide. Okay, so let's get into a couple more examples here. All right, and then after you go through this video and the other videos in this section, you're going to get quite a bit of practice balancing chemical equations. Okay, we've got a bunch of those questions in a homework assignment for you. All right, okay, so let's start here. We have hydrogen. There we go. We also have sulfate on both sides, and it stays together, so I'll just keep it together here. And then we also have an aluminum. All right, and this is obviously a single displacement reaction because we have our aluminum kicking hydrogen out and then taking its place with the sulfate. Okay, but we also have the same elements on our product side of the reaction. Okay, so we start off with 2 hydrogens. We have 1 sulfate and 1 aluminum. And then on the product side, we still have 2 hydrogens, but now we have 3 sulfates and 2 aluminums. Okay, so let's start off balancing just the sulfates. Right, so we have 3 on the product side, so we can just put a 3 right in front of the H2SO4. So that triples our SO4s on the reactant side and also triples our number of hydrogens. So what you'll notice is by balancing the sulfates, we've knocked the hydrogens out of whack. Okay, that's okay. Don't worry about that quite yet. Because hydrogen is on its own on the product side, it tends to be one of the easier ones to balance at the end. Okay, now let's take a look at our aluminums. So we have 1 on the left, 2 on the right. So we just multiply the 1 on the left by 2. That increases our number of aluminums in the reactants. Okay, and because that aluminum was on its own, we haven't changed the number of any of the other elements. Now, the only thing that is not balanced are the hydrogens. Okay, so what times 2 equals 6? 3. So we can put that right there. Okay, and that brings our total hydrogens up to 6. All right, so we have hydrogens 6 and 6, sulfates 3 and 3, and aluminums 2 and 2. So that one is balanced. All right, another one. we have P4 plus KClO3 yields KCl and P2O5. So in this case, we cannot keep our polyatomic ion, the ClO3, the chlorate, together because it splits. Okay, the oxygens are going to get ripped off and then go to join the phosphoruses. Okay, so let's go ahead and write out all of our elements. Okay, and go through this one. Alright, so on the reactant side we have 4 phosphoruses. Product side we have 2. Potassiums we have 1 and 1. Chlorines we have 1 and 1. And oxygens we have 3 and 5. Alright, so easy one to start off with. Let's just go with the phosphorus. So if we have 4 on the left, 2 on the right, all we need to do is put a 2 there. Okay, so that doubles our number of phosphoruses. Also doubles the number of oxygens. Okay, well now 3 doesn't divide directly into 10. Okay, so now we're a little bit stuck. All right, so this is where you're going to have to start going in and doubling everything. All right, until you can get it to work. Now, if we just go ahead and say, all right, so if we let's take a look at what we've got. Okay, because sometimes that can be really helpful. So if you do 3 into 10, you end up with 3 1/3. Okay, and that would give you 10 here. You really don't want to do that because you don't want to deal with fractions, okay, in this. But getting the fraction can actually help you figure out what you need to multiply everything by. Okay, so 1/3. So let's try multiplying everything by 3. So if we get 3 here, okay, let's go ahead and erase this one for right now. We'll come back to it. This one, oops, hold up, let me erase that as well. Okay, this one now becomes a 6. Okay, and this was a 1 before, so let's just hold off on that one for right now. Okay, so now we have 12 phosphoruses, okay, on the left side. We also have 12 on the right. Okay, so that's still balanced at least. Now we have 30 oxygens on the right. Okay, so 6 times 5. You have 30 oxygens. Can you divide 3 into 30? Yeah, pretty easily. It's 10. Okay? And then now we have 10 potassiums, 10 chlorines, 30 oxygens on the left. So now we need to balance our potassiums and our chlorines. So we put a 10 here, and that balances everything else. Okay? So there is a lot of kind of figuring things out when you work with balancing chemical equations. Okay? Now, had we multiplied everything by 6 instead of by 3, by 6 instead of by 3, okay, we would have ended up basically with a 6, a 20, a 20, and a 12. Okay, now what you notice with all 4 of these numbers is that they are all divisible by 2. Okay, so you do need to be careful and make sure that you have the lowest set of numbers, okay, for your chemical equations, because putting in 6, 20, 20, 12 is incorrect, okay, because you can divide each of those by 2. So you have to have them least common. Okay, so 3, 10, 10, and 6. So we've got 2 more examples that I'm going to go over in the next video. If I can find my pen, where did it go? Here we go.